Hey, what's up everyone? Today we're going to be talking about scalar and vector projections. Let's get started. Let's take two vectors A and B and pretend that vector B casts a shadow on vector A, constructing a right triangle in the process. Is there any way we can find a numerical representation of the shadow? Well, we can through the scalar projections, and we find this nice equation through this. Comp B onto A equals A dot B over the length of A. Let's do an example together. Find the scalar projection of B equals 3, negative 2, 1 onto A equals negative 1, 2, 3. First, let's construct our equation. Comp B onto A equals the dot product of A and B over the length of the vector A. We see that the dot product equals negative 4. And we find that the length of vector A equals the square root of 14. Plugging and chugging, we see that the scalar projection equals negative 4 over radical 14. Now let's go back to our shadow diagram, and let's consider how we can find a vector of this length in the direction of A. First, we'll take the scalar projection, and we know through the identity property we can multiply anything by 1 and it will remain the same. So let's multiply the unit vector with it. Thus, the vector projection is proj B onto A equals A dot B over the length of A squared times the vector A. Let's go back to our previous example, but this time let's find the vector projection. First, let's take our scalar projection, which was negative 4 over radical 14. And we'll multiply this with our unit vector, A over radical 14. After everything, we get this as our answer. Now let's review. Consider scalar and vector projections as a shadow that vector B casts onto vector A. There's a lot of confusion surrounding projections, so we want to make this as simple as possible. To find the scalar projection, we do comp B onto A equals A dot B over the length of A. And to find the vector projection of B onto A, we use proj B onto A equals A dot B over the length of A squared times the vector A. Here's an example you can do on your own. For the answer, click here. And remember everyone, understanding the concepts is only half the battle. Make sure you do plenty of practice to really hone these skills and master the material. Thanks for watching.